Hi guys, welcome back again. Math 135. We are covering section 1.6 today, and I really like this section. I think it's such a useful section. It's called a library of functions. What a beautiful name for a section. And what we're learning today are just some of the basic functions that you're really gonna carry with you throughout your math journey. So I really highly suggest that you get familiar with these guys. Except for, I shouldn't say except for, but these two right here, I just took this straight from the book. These two, I wouldn't necessarily memorize them, but you should know how to deal with them if you come across them. So I guess in that sense, you kind of are memorizing. Let me come back, guys, and talk about what are we covering today. We're covering two things: how to recognize and graph basic functions, and all together we have 12 of them, 6 on the first page, 6 on the second page. I took this straight from the book. Except I split it up slightly differently and ordered it slightly differently, but same functions. And the second thing we're going to learn today is how to evaluate and graph piecewise functions, which is not so hard. Just basically take a graph and you split it into pieces, or you take a function, split it into pieces. Okay, so here's a plan for videos. In this first video, I'm going to cover the first page of functions. There's 6 of them, and we're going to talk about those. Second video, we'll talk about the second 6. And then in the last 2 videos, we'll start covering the questions. So here we go. First video, we're talking about the first page of functions: the constant function, identity function, squaring function, cubing function, absolute value function, and square root function. So these are functions that we want to just stick in our back pocket. So anytime we come across them, we can just bust them out. We know exactly their general shape. We know how to figure out their domain range and basically what they do. Okay, so starting with the constant function, which I think is maybe the easiest one of all. And looking at this guy, constant function, it's of the form f of x equal to c. And this c is just a number. So see this c? That's just a number. So this is like, you see this as like y equal to 5, for instance, right? And then that will just be a horizontal line right at 5. I forgot to mention this, but I did say to, you're trying to get familiar with these guys, but that doesn't really mean that you memorize them necessarily. But what you want to do is you want to just be able to think logically about what is going to happen if I have a function like this. Let's say I don't remember the graph. You can always resort to graphing a few points. And you can always resort to making a table, right? So y is equal to some number, c. So that means if I plug in -1, it's going to spit out c. If I plug in 0, it's going to spit out c. If I plug in 1, it's going to spit out c. So then I go to plot these points, -1, -1 comma c, right there, 0 comma c, 1 comma c, and then you start to get the pattern, right? And then you just connect the dots to get your horizontal line. So that's the constant function. Domain is -infinity to positive infinity, because looking at it, I get all x values to the left and right, right? The range is only that c, because looking at the up and down values that I get, there's only this one height that I get. So I only get y equal to c, whatever c is. If it was 5, it would be 5. If it was 6, it would be 6. If it was -1, it would be -1. And then it's constant. We talk about increasing, decreasing, right? This whole thing is horizontal, so it's constant the whole way. And then it's also even, because if I flip it over the y-axis, then I get back on itself. Okay, so that's constant function. Next is the identity function. Super easy. F of x equals to x, which if you think more in terms of like how we usually write the names of graph functions, we often write just y equals to x, right? And so it's just this, this diagonal line, 45-degree angle. This is one specific case of a more general case, which is graphing lines. And we did a whole section about graphing lines. So we pretty much know how to deal with this guy already, right? You get y equals mx plus b. In this case, the b would be, the y-intercept is 0. So this would be like there's a 0. That's why it crosses right at the center. And then the slope, since it's just y equal to x, what's the coefficient for that x? Well, it's just 1, right? So it's 1x. And what is 1? 1 is 1 over 1. So that means from the starting position, you go up 1, you go over 1, up 1 over 1. And then you can graph your line like that. You can also always make a table, right? Plug in 1, you get 1. You plug in 2, you get 2. You plug in -1, you get -1. And so you see that it just lies on that line. Domain, everything, all x values, yeah. Range as well, because you go as far down as you want, as far up as you want. And then it's increasing the whole time, right? If you just read from left to right, you're going up the entire time. Now, this is an odd function because if you're to take this guy, rotate it 180 degrees, it lands back on itself. Okay, on to one of my personal favorites, the squaring function. Squaring function. I actually never heard it called a squaring function that I can recall. Squaring function, that's a weird name. Excuse me. We can call it just y equal x squared. Call it the I guess squared function, squaring. Well, they're calling squaring function. That does make sense. Also call it the quadratic, right? Basic quadratic. And well, how does it look? So again, if you don't remember what it looks like off the top of your head, just start with a simple table. If you plug in 0, you square it, you're gonna get 0. If I plug in 1, I'm gonna get 1. If I plug in -1, square it, you get 1. If I plug in 2, I get 4. -2, I get +4. So I got 0, 1, 1, 2, 4. -2, 4. Right? And then that's your basic quadratic function. Looking at it, the domain goes to the left forever, it goes to the right forever. That's why you have this -infinity to +infinity. The range, looking at it, start from the bottom and you can go up forever. So from 0 all the way up to +infinity. Note that they include the 0 because 0 is possible. It's decreasing. If you read from left to right, going from left to right is coming down until the center, right? So that's decreasing from -infinity up to 0. And then from 0 onwards, it's getting up as you read it from left to right. So increasing from 0 to infinity. And this one's also even. Well, you know it's even because that's an even power, but looking at it, if I was to reflect over the y-axis, then it lands back on itself. All right, so first 3 done. Again, just put these guys in your back pocket so that you're ready to pull them out whenever you need them. Whenever you encounter them, you won't be surprised. You know the general shape of those guys. Later on in the next section, we'll talk about how you can translate these basic functions. But we want to start with knowing at least the basic graph. Okay, next is x cubed. Again, if you don't remember, then just make a little table with a few values. I already have in mind, I always have in mind, okay, yeah, x cubed looks something like this, right? And if you don't remember though, just plug in a few points. -1, 0, 1 is a good start. You get 1, 0, and 1 if you cube, right? -1, sorry. Negative, because it's an odd power, when you plug in a negative, you're going to get a negative back. -2, you're going to get 2 for 8, right? With a negative. +2, you're going to get a +8. So I got 0, 0. I got 1, 1, -1, 1. I've got 2, 8. This is 2, 1, 2, 3, 4, 5, 6, 7, 8. So 8 would actually be up here. And then -2, -8 down there. Yeah. Something like that. Okay. So we got the picture. Okay. What else? This is getting messy, so I'm gonna take that out. Okay, yeah, so domain and range. The domain is, if you look, it can go on forever. If this arrow continues, it's going left or further and further to the left, right? If this arrow continues, it's going further and further to the right, so I get everything. -infinity to +infinity. And there's nothing that I can't put in this x. The range, also -infinity to +infinity, because it's going down forever and up forever. And it's increasing the whole time. Because as you read from left to right, it continues to go up, right? This time it seems to flatten out, but then it continues to go up. So it never actually goes down, and it's never exactly level either. I know it looks for like an instant it's level, but even at that center point, it's continuing to go up. Yeah. What? I mean, maybe for like a minute infinitesimal moment, it's not growing, but then it immediately starts growing again. So increasing the whole time. And then this one also has origin symmetry because the same reason, right? Well, it's odd. It's an odd function. And then if I was to rotate this 180 degrees, it lands back on itself. That's what odd symmetry is. Okay, 2 more to go in this video. Absolute value function. We've seen this before, right? It's just like, remember its shape is a V. absolute value. Oh, you know, I just thought about this. V, absolute value, and the shape is like a V. So, you know, like whatever little mnemonic tricks you can come up with to help you remember things are always helpful. The value, absolute value function looks like a V. And again, if you don't remember off the top of your head though, you can always resort to a little table. Just pick a few easy values. 0, -1, +1, always a good place to start. And it's going to spit out the positive regardless of what you input, right? So if I plug -2, I get +2, +2, you get +2. So I plug -1, I get +1, -2, you get +2. Like that, that's the function. Looking at the thing, all x values are possible. The range, it starts only from the 0 value and then it goes upwards, right? So from 0 on upwards. Decreasing the first half as you read left to right, right? So decreasing up to 0 and then increasing after that. So increasing from 0 onwards. This also has y-axis symmetry, making it odd. Y-axis symmetry, remember, means I can reflect over the y-axis and it lands back on itself. So that's the absolute value function. One more comment about the absolute value function. You know, later in this section we're covering right now, we're going to talk about piecewise functions. And piecewise function just means you split a function into two pieces, right? Well, another way to think about the absolute value function is it's got part of it where it's y equal to x. And look. Look at this guy up here. Y equals to x, remember? Right? Look, that's exactly the same for that part, right? So it's y equal to x as long as x is bigger than or equal to 0, right? But what about the other half? So the other half is very similar, except it's negative. So that part is y equals -x. And that's if you're to the left. So if x is less than 0. So another way to define the absolute value function, like the way we typically think about it, is it's a function that just spits out the positive, right, of whatever you input it. But you can also think of it, sorry guys, I have a colors in my throat. So as long as you think of it as two separate parts, then you could think of it as a piecewise function. So like first part that way, second part that way. Okay, one more in this first video. Square root function. Okay, another one of our friends. One thing I'd like you to notice about the square root function is its shape is actually very similar to the squaring function, and that's not by chance. That's because, you know, they're related, right? The square root, if you square it, you get back to the original. So these guys are very similarly related. Now, this is the form is y equals to the square root of x, or alternatively x to the 1/2 power. It means the exact same thing. Exact same thing. It's just different notations for that same thing. Sometimes it's more convenient to write things with these fractional powers because that helps us to like do operations with them. But sometimes it's more convenient to see it like this because that just helps us to visualize what's going on. Now, if I square both sides of this equation, I get x. I'm sorry, no. If I square x squared x, I get x, and I get y squared, right? So this y equals square root of x is actually closely related to the y squared equal to x. And remember, y squared equal to x, that's like if I was to, I wonder if I can do this. Hold on. If I was to take my graph and rotate it, then that's what I would end up with, right? So let's see if this works. Not sure if I can select this picture, this portion of the picture or not. Yeah, I don't think I can. Okay. Never mind. I was going to rotate this thing, but it doesn't let me do it. But what I would like you to notice, though, is that this portion of the square root function, it looks like half of the parabola, right? If I was to think of this guy as being like my x-axis here and a y-axis instead, then this would have the exact same shape, right? That's because they're actually closely related to each other. But let's come back to the graph of it, the same way we've been approaching the other ones. So let's say you forgot how the square root function is, although this is, again, another shape that you want to stick in your memory. But let's say you forgot. No problem. You We just pick some easy points. And what are easy points to take a square root of? Well, 0 is 1. 1 is also easy. I can take a square root of 4 or 9 easily as well, right? Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So I got 0, 0, 1, 1, 4, 2. I don't know why I shaded that part. And then 9 would be next. 4, 5, 6, 7, 8, 9. This is 9. 9, 3 here. Yeah, and see that gives you the general shape of it if you connect those dots. So that's the square root function. And if you were to draw in the bottom as well, you'd complete the parabola. But it's not a function, remember, if you can draw a vertical line and it goes through 2 points. Remember, we did that in the previous section. So that means you can only have, for it to be a function, you can only have the top half or the bottom half. Now, if I have y equals to negative square root of x, that would be the graph of that bottom half. Okay, well, let's talk about the domain and range now. So domain, looking at it, I can't stick anything. Let me get this out of the way. I can't stick anything inside of the square root that's negative because I can't take a negative square root. So the smallest value I could have is a 0. Hence, you start from the 0. You look at the picture, it matches, right? 0 onwards. So that's the domain, including 0. Range also doesn't go below 0, but then it goes upwards forever. I know it's slow increase, but if you continue going, you're getting higher and higher. So you can go as high as you want. So 0 to infinity for the range as well. It's going up as you read from left to right. It's going up the whole time. So it's always increasing from 0 up to infinity. Remember, we don't include the boundary points for increasing or decreasing. So this one is an open parentheses. And this one is neither odd nor even, because if I was to reflect it over the y-axis, it's not going to land back on itself, right? And if I was to rotate this 180 degrees, like that, let's see if I can, it looks something like that, is that right? Yeah, something like that. But it's not landing back on itself. So that is not symmetric across the origin either. All right, guys, so those are the first 6. And these guys should probably already have been familiar to you, but if it was, then it was a good review. If not, then these are functions that we do want to be friends with. Okay, I'll see you in the next video for the next 6.